You're looking up at the night sky. That same night, sky your parents looked at, and their parents before them, and people who lived thousands of years ago. The stars are there, exactly the same, stable, eternal, unchanging. But here's what's actually wild. It's all a lie. The sky you're seeing is changing right now, just not on the timescale of your life. Stars are burning out, black holes are appearing, galaxies are drifting away from each other into darkness. And if you fast forward time far enough, not years, but eons, the sky changes so completely that the human word sky just stops meaning anything at all. Listen, I'm serious. In 1,000 years, if the world survives, it will look up at a night sky that's noticeably different. Not revolutionary, but noticeable. Betelgeuse, that red supergiant hanging warmly in Orion's shoulder, might already be gone. We say might because astronomers are already placing bets on it. It could happen tomorrow, could happen in 100,000 years. But when it explodes as a supernova, for a few days, it'll be brighter than the moon in the middle of the day. People looking at the same sky you're looking at might see it, or they might see something even worse, one of a dozen other supergiants beginning its final show in the reverse direction of time. But let's raise the stakes. 100,000 years. 100,000. That sounds impossibly far away, longer than all of written human history in all its forms. But plug it into the cosmic calendar and it's something like tomorrow evening. In that span, several generations of stars will die. Ordinary stars like our sun will leave the main sequence, balloon into red giants, then scatter their outer shells into space like carbon clouds. Wolf-Rayet stars, those raging monsters shedding their own mass at 2,000 kilometers per second, will heat their cores and speed up before exploding. A few ordinary novae, binary systems where a white dwarf siphons gas from its companion, will flare and fade into scars. And here's what's terrifying. In 100,000 years, some of the oldest white dwarfs in the galaxy will cool so far that they formally change status. They'll stop radiating any meaningful amounts of light. They'll become what astronomers call black dwarfs. And here's the thing. Black dwarfs only appear when a white dwarf has cooled for an impossibly long time. Being a black dwarf isn't a property. It's a memory. It's the remnant of something that once was a star. In 1,000,000 years. Wait, let's stop at 1,000,000 years and really think about what that means. 1,000,000 years ago, there was no such thing as humans. Hell, there wasn't even such a thing as humans in our understanding. 1,000,000 years forward, if we just run by the physics we know, things happen that break what permanent means about a star. In 1,000,000 years, ordinary neutron stars will still be spinning, some of them hundreds of rotations per second, but they'll be cooling down gradually. And here's the thing, and this isn't a minor detail. When a neutron star cools, it changes physically. The crust hardens, internal structures collapse, creaking, frozen celestial mechanics. In 1,000,000 years, several of the most famous pulsars we've actually observed will start emitting fewer radio signals. They'll start fading. They'll be less like lighthouses and more like radios forgotten in the deep. And here's something truly heavy. In 1,000,000 years, matter moves differently. Black holes, which we think of as eternal, will start noticeably evaporating. Stephen Hawking showed this. Black holes aren't absolutely black. Through quantum fluctuations near the event horizon, they slowly radiate energy away. This is very, very slow. A black hole the size of the sun would take billions of years to evaporate. But in 1,000,000 years, the smallest black holes, microscopic by astronomical standards, the size of mountains, will start to flash. They'll burst in gamma-ray flares and simply vanish. In 1,000,000 years, the universe will lose some of its black holes just because they were small enough that Hawking was right about them. Now we're entering territory where we can't pretend this is just a zoo of stars with a few more corpses. In 1,000,000,000 years, billion, that's 1,000 millions, galaxies are flying away from each other so fast that light from the most distant ones will never reach us. The universe is expanding, and that expansion is accelerating because of something scientists call dark energy, which nobody understands but which seems to make up 3/4 of all existence. In 1,000,000,000 years, the cluster of galaxies containing us will be absolutely hopelessly isolated. Light from another cluster won't arrive. If any civilization existed 1,000,000,000 years from now, they'd look up at the sky and see only one galaxy, theirs, surrounded by darkness expanding into infinity. They'd think they were alone. And in some sense, They would be. By that time, our own sun is long dead. About 5 billion years ago, it swelled up, consumed Mercury and Venus, maybe consumed Earth, depends on how far its core expanded. It left behind a white dwarf, Earth-sized, an object whose initial mass was like our sun's, but so compressed into a ball with a radius of 6,000 kilometers that its density defies imagination. In a billion years, that white dwarf will have cooled so much it barely radiates at all. It's already a black dwarf, and around it, in black emptiness, orbits the remnants of planets if anything remains, rubble, ice, traces of what once seemed permanent. By that time, some amount of solar black holes will have evaporated too, not all, but some of the smallest. In a billion years, solar clusters expand. Stars that once had to orbit close to each other scatter away. Black holes that ever formed within them will either be ripped apart by expansion or, in some cases, orbit so far from everything that they black hole the space they came from entirely alone. And I'm serious. If you're following this narrative right now, and you still have your capacity to be amazed by scale, then here's what I'm asking. Stick around. Because it gets worse. Not darker, not duller, just deeper into the principles that govern all existence. And if this moment moved you, things really start getting wild. In a trillion years, trillion, what a number that doesn't even have a word for it in most languages, the universe becomes what astrophysicists call the era of decay. Almost all stars are already dead. Almost all the ordinary processes we associate with solar systems or galaxies, star birth, star death, explosions, novae, supernovae, all of that's been gone for ages. Instead, the universe is populated by a narrow form of matter. Black holes, white dwarfs, neutron stars, left absolutely cold, dead, radiating imperceptibly. Everything that animates the world is gravity, friction, thermal diffusion, and finally, Hawking evaporation. In a trillion years, the largest black holes will start noticeably faster evaporation. They'll release their last energy as radio waves, then vanish, leaving behind acquired microscopic remnants. In a trillion years, the universe, think about this calmly, is a universe without 100% of what we see as stars, as what the last people on Earth would see when they look at the sky, as a universe that looks already dead, breathing strange forms of physics through pure gravity alone. And here's what really gets me. We live in a moment when the sky still shines, stars still burn, novae still flare, explosions still happen. In many senses, on a cosmic scale, we're living in some kind of youth of the universe, still in a moment when something is happening, still when the world is loud. What do you think about that? What idea strikes you most? That the sky will fade to black, or that we're looking at it now while it's still burning,